Right. So again, this is the question number 22, and I'm just trying to understand the question. So we have this AB equal to CAD. So this E will be here, and this E will be here. Wait, am I? Okay. We need to, if the triangle PBD, so further given that PBD is equilateral. Okay. Um, find angle ABC. So any ideas? Need to just do, also this AC equal to 2AB is given. So let's see. So because this AC equal to 2AB is given, I may try to uh, is not equilateral, but let's try to draw the median. Okay? I'm just drawing this line DM so that AM equals to DM. Okay. I don't know if that is a good thing to do. So if these three are all 16, these three are all 60 equal. Yeah, the median looks like a string. The median is a construction is it going to be used? So what happens now you see is that this AB becomes equal to AM. So that is okay. This is X. X. Okay, so this is 120. These things we know, right? This is what now? This is 60 minus X. Is that correct?
Yes, sir.
Yeah. So that is so that tells us something. That tells us that this top angle is actually also 60. That is good, right? That is a good thing. 60. Now you see the fun. Now the interesting thing is, we should have seen that much earlier, right? So that's a very simple calculation that gives us. Now I have drawn the DM so that I'm able to use this fact in an easy way, right? So this AM is now equal to A. But what can you say about ABM? What can you say about ABM? So you agree that AB equals to AM? Hello?
Yes, sir.
Yeah, AB is equal to AM because I have just bisected AC. That was the very purpose why I bisected it, so that I am able to use that fact, right? I was expecting that the angle B, this angle is also equal, so maybe I can get some similar isosceles triangle, congruent triangles. But now you have ABM. So look at the so when you if you get confused, I mean I get confused many times in maybe some complicated things. This also. So the point is that you draw it separately. Okay. Ask yourself, okay, I'm looking at ABM. I'm looking at this is 60 degrees. There's one source of information. The angle information is telling me it's 60 degree. And this other information is telling me that AB equal to BM. What can AB equal to AM? What can I say about this triangle? Such a triangle. Equilateral. Yes or no? Right?
Yes, sir.
Right? It becomes equilateral. And so we were given one equilateral triangle, but now we have another equilateral triangle. Okay. So you know that ABM is 60. So now what can we say? So we have 60 plus x minus 60. So this is again x. So maybe we did not get exactly what we wanted. Right, so that is 60, that is also x, and so this is also x. Hmm. And hmm, it's not done. The angle is not coming. Hmm. This problem is nice. It's so we are missing something here. We need to come here also. This angle C. How much is the angle C? Sixty. 60 minus x, right? 60 minus x. Because the total has to be 180. Hmm. I know that this is x, that is x. No, it's not x, that is 60. Yeah, this is 60. Yeah, but do you see that it is 60? Maybe that's a little difficult to see. So let's try to explore that and let's try to prove that that is 60, if it is correct. Yeah, here we are using a bit of technology. Let's because I know a few things, so I want to get it faster. So can you show that this angle? So now your task is to show that ADM is 60. So Something earlier was telling me that it is wrong, it cannot be 60, but now it is 60. Hmm. Is it easy? Let us see. Hmm. Yes, you can use like this. So let's say that this is y. Okay. Then you look at ADM, and you have x plus y plus oh no. So there is more. Hmm. Yes, this is like a theorem, so I have to tell you. Um, maybe let me say that on a new page. Okay, let me say that on a new page. All right. Hmm. So this thing I need to tell you is, let's say that we have a quadrilateral. This is a very useful theorem, quadrilateral, and something like. Okay. Now let us also assume that these two angles are same. Okay. These two angles are same. So this is x and this is x. Then can you show that this is, suppose this is y, then what is this? Can you say it is also y? So try to see what it is. It should also be y, right? Because you see this is z, then this is x plus z. Yeah, that's fine. But then x plus y, so this is also x plus y from this angle, right? X plus y, this is 180 minus x minus y, so x plus y. So y equal to z. So this is a very simple thing, but it's a remarkable thing in some sense, right? Once you know one pair, then other pair also. What is more interesting is, now if I tell you that this is z, then what is this? So let us try to show that that is also z. Okay? So you see, just so we are just starting that from this, that this one pair of angles like this, like this angle and this angle. So one pair of angles is same. Starting only with that, and we are able to generate more information. I mean, this happens for a very nice reason, which we will maybe see later. Why? No, this that we have proved that those two are equal. But if this is z and this is w, then I maybe it will not come like this. This is t and this is just putting variables u. We want to show that t equals to u and z equal to w. Okay? Can we do that? So we know that x plus y plus z plus t is 180, right? And so is w plus u plus y plus x. Hmm? So what does this tell me? that z plus t is equal to w plus u, which you already need. It's something that you already need. That z plus t equal to w plus u. But do we need some more information? Do we get anything more? Not from this picture, right? So how do we prove it? It is true though, that it is a very remarkable fact. So we need to go into this. So let's forget all this. So it's true, but it doesn't follow like so easily. So that is something which just does not follow from angle chasing, which does not just follow from angle chasing. Okay, but when we prove it, you'll see it is true, and that's why it's a theorem. It's a theorem in cyclic quadrilaterals chapter. Cyclic quadrilaterals chapter you will see in your maybe 10th grade or something NCRT book. You'll find it. This is a very important theorem there. So it's nothing hard, but it's just maybe in the next grade or something. Officially. So let us see. Point I'm trying to make is that once you have this situation, okay, then the triangle, the circle that you use for this to pass through this triangle, it will not happen in my picture, but um, what I'm trying to say is that the circle that you use, you draw the circumcircle of this three. So given 3 points, you get a unique circle, right? This circle will actually also pass through this. We have to show that. So let us see it in more detail. Suppose I give you 3 points. So let me ask a few questions. Can you make a circle through those 3 points? That's the first question.
Yes, sir.
Okay, you can make it. How many circles can you make?
One.
Only one, right? So you can make exactly one circle and not 2 circles. So given 3 points, you get a unique circle. It's a simple fact, but it's a fantastic fact, right? Now, if I take a quadrilateral, so given any 3 points, I can make one circle only. So then if I take so now let me ask you this. Now if I take any point, how many circles can you make passing through these 4 points? All the 4 points. It may be 0, right? You may not have any circle passing through 4 points. Is that clear?
Yes, sir.
Right? Because as you said, when you have 3 points, you can make only one circle. So if your 4th point is not on that circle, then how can you make a circle passing through those 4 points? Because if you can make a circle passing through the 4 points, then you'll get another circle passing through these 3 points, but that is not possible. Okay. So any 4 points, if you have, it's not necessary that you can have a circle through them. Okay. But sometimes, but obviously, there you can sometimes. You cannot always, but if I bring this D here on the circle, then it is possible. Right? So those quadrilaterals, right, for which I have a circle passing through those 4 points, those special quadrilaterals, they are called cyclic quadrilaterals, right? Cyclic. So that is the point. And you can only have one circle because 3 points say you only get one. So with 4 points, you cannot get more. Now let us investigate something. When you have a circle and you have this angle, okay, let us investigate this. Let's say this angle is x. Okay, then this angle, we want to know how much is this. Now, what is this point? This is obviously the center. Okay, this is, we are proving a theorem, so it's okay if it's a little hard. Okay, this point O, we want to understand this angle. It looks like double, right? Little bit. Okay, we want to prove that it is actually double. It's actually 2 times x. So how to? So again, it's simple. We make this, join this line. Okay? Now the whole thing is x, but it's not divided into 2 equal halves. Okay, so this could be some y, and this could be, this is then just x minus 1. Okay, now you tell me that if this is y, then what is ABO? O is the center. So look for an isosceles triangle. It is isosceles triangle in the picture. So look at AOB. There is something in there. So see, O is the center. What does it mean about AO and OB? Yeah, try to work it out. AO is the radius, OB is also the radius. Right? So we know that AO equals to OB. Try to use this to say about the angles. Hmm. Hello? No? No, but that this should not be difficult. Hello? Are you there?
Yes, sir.
Yes, right? So, I mean, so try to work it out. See, AO is equal to OB. Then what? Then if OAB, this angle is Y, then what should this angle be? That's all I'm asking. What is AB?
Why?
Yes, so that's easy, right? That's what I'm asking, right? That's all. That's why. And similarly, this is x minus y. Yeah, I understand. Suddenly we have sort of gone to a topic, but this is a topic now that we need to pick up. Okay. Now use all this to figure out BOC. What can you say about uh, not AOC? I'm sorry. I'm interested in. I mean, AOC is fine. BOC is what we want. Maybe that was confusing. So again, you just do calculation. So this thing, what is this one? AOB is 180 minus 2y, right? So what is AOC? Similarly, no. So x minus y, x minus y. So AOC you should be able to say. Have a look, see. So it is also similar, right? So focus on this triangle AOC. So we have this triangle AOC. This is x minus y. Is the variables causing a problem? X minus y, x minus y. I'm just drawing the picture separately, right? And you know that AO is equal to OC. I mean, you don't even need that. I'm just can find the third angle, right? AOC. So you have a triangle. Two angles are given. Find the third angle. Wait. So then, what's the problem in this? Finding the third angle. That should not be difficult, right?
180 minus 2 whole x minus y.
Yeah, that's all, right? So then that should be coming easily. So this is just the work that we have to do, right? It's just the calculations, simple calculations we are doing, and then we'll combine them into a nice theorem. So then we have to take the steps and get to the theorem. So this you also know. It's 180. Now you tell me the last angle. BOC. What is BOC? Which was the angle we are interested in. So we just do the calculations. You shouldn't worry about the variables. Fine, let the variables be there. We know that BOC is 360 total angle minus 180 minus 2y minus 180 minus 2 x minus 5. So you can do the calculation. So you do it and tell me what you get. We'll get something very nice in the end. The intermediate steps are a little, but the final answer is very nice. So simplify that and see what
2x.
2x, right? So in the end, we get a wonderful answer, right? What we get is that you start with x, so we can forget all this now. A little bit work, but we get a very nice result in the end. Something to learn. You see, so we had to introduce new variables, we had to use all the things. Finally, we got. Okay. So if the angle is x there, then the angle at the center is 2x. Okay. So I will not prove more things today because I think will become a little bit too much. Just one small thing I will now prove is if this is x and this is 2x, then this is 2x, that is x. That is okay, right? But then if I now ask you, draw this D, then what should this angle be? That will also be x. That's the nice thing. Because see, did we use anything special about the point A? No, right? We just said that whatever that angle is, the angle at the center is double of it. Think of it in this way. If calculations are a little boring, it may not be, that's your taste. Yeah. But another way to put it is, look, if the angle at the center was 2x or x, whatever it is, then the angle at A was half of it. A was just a point of the circle. Zooming out, right? Just a point on the circle. So if you take some other point on the circle, well, there also situation will be same. We did not use anything about A being special, right? You can do the same because A was just a point. D is also just a point on the circle. Also x. Any point on the circle you take, it's all x. I mean, they have to be above this chord, obviously, right? Because again, if this is x, then you do the same calculation and you get that this is 2x. Same thing, right? So finally what we get is this very remarkable picture. You have this is x, you have this is also x, not changing, still x. You see, you're trying to decrease it, but then by the way it's on the circle, it increases on the other side, and it's also x. Now it looks like a nice, right? So you move on that circle, and everywhere you get the same angle x. Okay, so we will stop here. This is, so you have to practice this. So NCRT, you have to check the correct grade, and you look at the chapter on cyclic quadrilaterals. This is the name, not the circles chapter. Circle chapter, lower grade or higher grade will be different. Cyclic quadrilateral chapter or circle geometry. This is the first theorem or first three theorems we have proved. Then you have to just practice the first few problems. Okay. So I'm just stopping a little early today. Please do this, and then we'll meet next week, and maybe we'll make up for the time. Okay, but don't worry about we did cover stuff. Okay, so do this from NCRT, and then do this for this week. Okay, all right, and see you.